To introduce you, Katarzyna Wojczulanis-Jakubas, who's a researcher from the University of Gdańsk in Poland. She works with seabirds, with little auks, and she studies aspects of behavior and parental care, which are very similar to what most people here do with forest passerines. Of course, not everybody works with forest passerines. Some people work with bigger birds. But I think it's a very nice perspective on parental care that can be compared with what the more typical systems that we know. So thank you very much, and thank you for coming.
Thank you, Diego, for the introduction. Welcome, everybody. It's a great pleasure to be here and to talk to you. So I'm going to talk about the parental care from a perspective of seabird, pelagic seabird, which is a little bit different from that, what is the most common in the perspective in the literature on parental care. But before that, I would like to acknowledge a few people from my group, and what I'm going to present today is actually the output of our common work. So this is Antoine Grissot, and then Marion de Vogel, Dorota Kidava, and Dariusz Jakubas. So this is like a small group which works on this one of the avenue we are exploring in polar ecosystem, like parental behavior. So I won't say anything new for anybody that parental care is like a widespread strategy which increases the fitness of the offspring. That's kind of obvious that the more amount of parental care parents invest, the higher is his offspring fitness, and also this of the fitness of the parents, because then they will survive better. A pretty recent paper also highlight that actually protracted parental care, protracted provisioning is likely to stand behind the evolution of large brain size of large brains. So parental care is actually essential, but it doesn't come without costs. I would like to highlight these costs are not that straightforward as it comes to the parental care. I mean, it's quite obvious that it costs time and energy of the caring parents, but it's this cost of the exploitation of the parents is not that straightforward. But another thing and more important here, what is related with the cost of parental care is the lost opportunity to mate with other mates. And then if you look at the issue from the perspective of the Darwin-Bottomland paradigm, where we've got like a big difference in the rate and size of the gamete production. We've got biased sexual selection, and that actually predisposes females to take more care than males. This is because females may not benefit with, I mean, they can benefit more with mating with multiple parents, but they won't really increase the number of the offspring. While for the males, this is a very different situation. The more females they can mate with, the more offspring they may have. So that is very basic sex differences, which predisposes the females to parental care. But of course, on top of that, we've got other eco-correlates, which modifies these things like ecological, environmental conditions, which may very much affect this sexual bias, and then also demography. So because of this interplay of different correlates, we've got a wide variety of different breeding systems in animals, from no care to some care, and then we've got female care only and male care only, and then biparental care, which is the core of this talk today. And then within the animal kingdom, birds are actually quite unique in terms of the parental strategy because most of them exhibit this parental care system. So we've got two parents and both are involved. Sometimes not really equally, one does a little bit more than the other, but still there are two parents involved in biparental care, which is kind of unique compared to other systems where this biparental care is not that frequent. So within avian family, we've got male and female caring for the offspring, and this male contribution is quite intriguing given this basic sex differences. Even if the environmental condition changes, there's evolutionary interest of males and females, then there's a basic sexual difference in the potential, reproductive potential, very much affects this parental performance. So whenever we've got this biparental care system, from the many studies, actually the information which comes out is this cooperation of the two parents is kind of conditional, especially on the side of the male. But very recent review of Simon Griffin highlighted the question of parents' cooperation to be like an alternative evolutionary force of the parental care system. Because sexual conflict over parental care is one thing, and it may be very apparent in some species of very short life history, and but then there are other species which have very different life history traits, and for them this sexual conflict is not that apparent. For them, the cooperation is likely to be like a very meaningful way of performing this parental care. So most of the studies performed on parental care is done in this perspective of sexual conflict, while pretty recently we can see a trend to look at the things from the perspective of the cooperating parents. And then we can see Griffith actually highlights there are species which could be like, we could expect them to cooperate greatly, and if so, they could be like long-lived species with literally little or at least little partners replacement. And this is where the seabirds come, because seabirds are long-lived animals, usually with long-term pair bonds, socially and often genetically also monogamous. So the sexual conflict is really hard to see. And so for this talk, I would like to actually focus on pelagic species, which is the little auk. And this little auk is specific on its own, but it also shares all the life history traits of many seabirds. So this is long-lived species, like up to 20 years can live with long-term pair bonds. They mate for life, although there may be some kind of mate replacement after the partner's death. And then we've got pretty balanced sex ratio, like similar survival of the sexes, and also high synchrony of breeding. So there is no really external factors that would enforce this sexual selection. And this is also apparent when we look at the extra pair paternity within that system. It's on a very, very low level. It's actually considered to be genetically monogamous. And then, because of the environmental conditions, two parents caring are actually crucial to raise the offspring successfully. So we've got pretty long and extensive biparental care, where the partners share their labor pretty equally. I mean, if you look at the most relevant for the parental care birds activity, like the incubation of the egg and then chick feeding, you can see both parents contributing pretty much, and then male actually contributes even more for the chick rearing sometimes. So at the end of the chick rearing period. So here we've got the system where we've got two parents caring and then males investing in the offspring, somehow losing this, potentially losing the mating opportunities, other mating opportunities, but the system actually makes the thing like they don't really have anything else to do, just to care. So we would expect in the system that if we've got these two parents so much engaged in the breeding care, in the parental care, they would even more benefit if they could adjust their behavior to each other. So we look at the coordination of various parental care activities. We look at the partners when they are feeding, and we explored if they can coordinate their feeding somehow. Then looking at this coordination, we look how it may change over the time, and then how this coordination varies in respect to the environmental conditions. Then we also ask the question how pair quality, like overall quality of the pair, may affect this parental coordination. So for the very first question, do little ox parents coordinate their activities? We used the video recorded data of the focal parents, where we could, of which we could establish the duration of the foraging trips. And we focus on the chick rearing period when the parents perform like the most meaningful, or like the easiest to measure parental activity. And yeah, we wanted to see how the parents actually adjust their behavior to each other. And before showing you any results, I need to also tell you about some specificity of the little auks, because they are pelagic seabirds. They forage on the sea, and like as close to the colony as possible, which is up to sometimes 200 kilometers. It varies among the years and may be different. But what is the most important? There are two types of the foraging trips the little auk parents perform, like short trips, which last up to 8 hours, and long trips, which last up to 24, even 30 hours. And these are trips which are regularly performed in alternated pattern, like whatever colony study site you consider. Like here you've got several colonies considered. You can have a series of short trips denoted with the dark gray bars, and then a long trip, and again series of short trips. So we've got this bimodal foraging strategy for the little auk. And then we also know that this bimodal foraging strategy is very important for the adults caring for the chick, because we know that short trips, they serve primarily to provision the chick, while long trips, they serve to restore own body reserves of the adults. This we know because when we measure the body mass of adults between the consecutive short trips, we can see they are losing their weight, while after a long trip they are increasing their weight. So that's the strategy which allows adults to survive this period of hard work while caring for the chick. But from the chick perspective, it's like short trips. They indicate a short waiting for food, while long trips indicate long waiting for food. And when we've got two parents caring, we can imagine different scenarios. The worst is like the two partners. They are living together at the same time for the long trips. and then together also perform in the same time the short trips. That means from the perspective of the chick, very long waiting for the food and then series of frequent feeding, which may not be the best strategy for the rapid development. Then on the other side of this continuum, we can expect we'll have the best scenario where the parents adjust their behavior the way they avoid the overlapping of long trips. So when one performs short trips, the other performs the long one, and then they change. This is the scenario we would expect to happen if the partners truly collaborate with themselves. So we pose such a hypothesis that this bimodal foraging strategy actually should favor the evolution of such a coordination of the behavioral coordination of the parents feeding or foraging. So for that, we first calculated the amount of the time the long trips of one parent overlaps with the short trips of the other parent. That was our measurement of the coordination. And then using this real data, we performed a randomization, shuffled these blocks, time intervals, and created distribution of this overlaps which could happen by chance. So you can see like this randomization happening and then distribution growing. And with this vertical line, you can see the observed value, which is much beyond the most of the distribution. So the values which could happen by chance. Then of that, we could calculate the index of the coordination, like relative to chance, which you can see on this axis, and then we could see that this negatively correlates with the variation of the time among the feeding, which is like the perspective of the chick. So the higher coordination of the parents in performance of these foraging trips, the lower variation between the feedings, which we believe should promote faster growing of the chicks. So to answer that question, we can about the parents' coordination, we can say yes, they do coordinate. At least they do coordinate the foraging trips, and it's potentially adaptive. The second question was about the coordination. Does it change over the breeding season? So we used the same way collected data, like video recorded material from the focal individuals, individually marked. And then we collected this material for different stages of the breeding season, both during the incubation and during the chick rearing. And no matter if we consider the single period or the periods like incubation and chick rearing or the whole breeding season in total, we expected increase in the coordination of the parents, and this is starting from the very beginning. And this is because of the changes in brood demands. When you consider separately the incubation and chick rearing, for both periods, you will expect the higher parental coordination because the brood demands are like higher. During the incubation, the chicks, the eggs has to be incubated more and more intensively because of the developing embryo, and for the chick rearing at the beginning, the chicks have really great needs because apart from the need to be fed, they also have a need to be like brooded, warmed up in this Arctic summer. So at the beginning, this This is really, really hard for the parents, but then they also need more food. So we expect that this growth and also the hormones changes over the time, and they change in a way that we would expect like higher parents' engagement into the parental activities. And also the familiarity effect, we would also expect that would favor this increase in the collaboration. Then we were not really sure about what will be happening at the end of this breeding season, but we expected either it will be growing continuously because of all these reasons, or it will stop at some point and then even decrease because some kind of mechanistic constraints or changes in the brood demands, we cannot really evaluate that precisely. And also because of cumulative effect of parental effort, colloquially speaking, they are like more and more tired after the season, so they may be less coordinated. So we look first at the incubation, and for that we calculated the overlap between foraging of one partner and incubation activity of the other. We look at that at the different stages of the incubation, which lasts normally like a month. And then we can see there is an increase, linear increase in this index. We considered here 2 lines. If you wonder why we've got we've considered here 2 seasons. If you wonder why there are 2 lines, but the season, it's not. It wasn't really the aim of the study, but we had to include that in the model because of this interannual variation. And you can see this year has a significant effect, so it has to be in the model. Whenever we are considering the coordination of the parents, we need to consider the environmental effect, but whatever conditions are, it seems like during the incubation, this coordination of the parents increases. And then for the chick rearing, we again calculated this overlap of long and short trips of the partners, so the same as we did it before. And we considered 2 stages, like early chick rearing period, which is the first week of the chick's life, and then mid-chick rearing period, which is the second week of the chick's life. And then again, we had 2 seasons, and we had to consider this season effect. And then we can see there is a difference between early and mid-chick rearing for one season, but not for the other. So again, it highlights the question of this environmental variability and the importance to consider this effect in the models. But it seems like the coordination of the parents, it decreases over the chick rearing, or maybe the same. So to conclude about this question, we can say that, yeah, for the incubation, this coordination of the parents apparently increases, and then during the chick rearing, it may decrease also, but it very much depends on the season, on the situation. The third question, how the coordination level varies in respect to environmental conditions. We considered for that data for multiple seasons, and then data from the feeding of the little auk parents, and to consider that in the respect to environmental effects, we used 2 environmental measurements. The first one is like a sea surface temperature, which is a very good indicator of the oceanographic conditions around the little auk colony, because little auks, they are very much focused while foraging with the Arctic zooplankton items associated, so zooplankton items associated with cold waters. And then if we've got a higher temperature, sea surface that affects very much the assemblage of the zooplankton. And then this zooplankton associated with warm waters, Atlantic waters, is much less much less energetic. And then we also considered the zooplankton energy of the food load, like the energy of the food load. And that was also like a proxy for the quality of the season. So of that, what I want you right now to remember is like when the situation is favorable, is good, then the sea surface temperature is low, and then zooplankton is of a high energetic value. So we managed to collect data for 7 seasons, and here is this upper panel reflects this data. We've got the coordination index calculated in the way I showed you at the beginning, and you can see there is some variation within each season, but between these all years, all these time points, there is no differences. While here on this graph, you can see sea surface temperature, and you can see that for this first 2 seasons, the sea surface temperature around the colony was pretty low and then was much higher, although it varied a little too. Anyway, if you pull all this data from the favorable and unfavorable conditions and compare, you won't see any difference in this coordination level. So it seems like this coordination, at least considered like that, doesn't really change much in respect to environmental conditions if these environmental conditions are expressed with this sea surface temperature. Because when we look at the energy value the parents bring to their food, it seems like in the seasons where the energy value is higher than the others, then the coordination index is also higher. It's never very high. You can see by the absolute value, which is like just a little bit more than 0, but it's higher than in the situation when the food is of lower quality. So higher caloric, it seems like higher caloric value, which means better environmental conditions. It promotes somehow the coordination, or the other way around, we can say that actually in good environmental conditions, the parents probably can afford some kind of behavioral adjustment in respect to each other. But in worse conditions, they are probably struggling enough to get the food, and then what is doing the partner at the same time is of less importance. Yeah, so on average, we can say environment doesn't affect that much the coordination, but probably in more extreme specific situations, this level may change. So the fourth question and the last question we asked is about the importance of pair quality for the parental coordination. This is the question which we just started to explore. So the data I'll show you, they are not yet like very representative. I mean, they haven't been yet published. We are still in the progress of the collecting data, but what we've already have is very promising. That is why I decided to show you. So the thing is, like, when we look at the parental coordination, no matter if it's the incubation period or the chick rearing, so these are these 2 plots we've already seen, we can see there is a lot of inter-pair variation, like within this vertical axis, there is a lot of variation. And if this is the case, it means the pair on its own, it has its meaning. And when we compare the parental coordination index for the chick rearing for pairs we've been monitoring for more than 1 year, like 2 or 3 years, we can see there is a pretty high repeatability of this parent or pair performance. Like, we've got pairs which are very highly coordinated, and then they are coordinated no matter what the season is. And then there are also pairs which are not that much coordinated, and they are kind of consistent in their performance. So to somehow grab this question of pair quality, we consider the duration of the pair bond, and we assume that new pairs, newly formed pairs, should be less efficient in their coordination than pairs, the partners which know each other for a longer time. And this is pretty problematic for the little auk because we cannot really establish precisely the absolute duration of the pair bond. And then another thing is like they are pretty they've got high survival, and also they are pretty faithful to each other. So we even working in the same colony for many seasons, we cannot really have naturally cannot really have that frequently newly established pair. So that is why I'm saying we still need more data. But from that, what we have, it seems that newly formed pairs, they've got a much lower coordination index than those which are together for some time, at least 2 consecutive seasons. I mean, this is here in this new pair bond group, we've got only 6 points, but if you compare this to 2 groups and randomize these points between to calculate the difference, this is the distribution you can get from this procedure, and here is the observed value. So it's very promising and showing that older pairs, like pairs with better experience, they've got also better achieve higher coordination. So yeah, to conclude about that, this pair bond duration, it seems to matter, but for this specific question, we need more data about the pair bond duration, also other hormones and perhaps other measurements. So as a take-home message, I would say that little auk parents, they do coordinate their activities, like they care about themselves while caring for the offspring, and they mutually adjust their behavior. They do that particularly well during the incubation period, and it gets better over the time. During the chick rearing period, this coordination is much less visible, although in some seasons at early stage it may be more visible. But it's important to highlight that this is very much season dependent. So the environment, which is like the season, seems to affect the coordination, but this mechanism behind are actually to explored. So with this slide, I would like to thank you, and if there are any questions, I'm more than happy to answer.
Thank you very much for a very nice talk. Any questions?
Thank you very much. I would like to know if you have any idea about how do they communicate between their parents?
Yeah, that's a good question. The default answer could be when they are seeing each other, they can exchange the information somehow, like they are very vociferous, so and vocalizing while meeting, so that could be the way, but it's really hard to measure that. But another thing is also like via the chick. This is actually something what we want to explore right now. Because when during the chick rearing, they hardly meet at the colony. Like when one is out, the other may come to the colony and then quickly disappear. So from time to time they do meet, and then they do vocalize, and they can actually communicate somehow. But for most of the time they are don't really meeting each other, but we believe they can do a lot of information through the chick behavior. And because when you feed your chick within your short trip sequence, then you don't really expect it to be that hungry. You're kind of on control of the situation. But when you are coming back from a very long trip and you can see your chick is very, very hungry, it may mean that your partner failed to feed it. But if you are coming from a very long trip and the chick is not that hungry, it means the partner was doing their job. So this may be one of the mechanisms, but I wouldn't really exclude that on top of that, we may have like a direct communication between the partners.
Thank you. And do you know what happened if one of the parents just disappear, for example, died or, disappear?
So yeah, we have kind of anecdotal information on that because it rarely happens like that, and then very much depends when it happened. I mean, when it's during the breeding season. Again, very much depends on the stage. If it's an incubation, it's soon gonna be abandoned by the parent that left. I mean, it will keep incubating, but for a while, and then we'll just abandon the eggs because it's impossible to warm up the egg for such a long time. I mean, they need to leave the nest for 12 hours, and 12 hours in Arctic, in the conditions of Arctic summer, it's too much for a developing embryo. If it's the chick rearing, then parents will continue the feeding as much as possible until the chick is alive. But yeah, it won't be sufficient. We haven't been doing proper experiment, but we've been deploying birds with GPS loggers, which they are okay in terms of they don't really make the adults disappearing for good, but they make the adults feeding less the chick. And so we've got kind of situation when one parent is kind of burdened with the GPS logger, so cares less than should. And then the partners somehow try to compensate, but rarely can actually do it because they are already riding on the edge. So then you can see the chick is actually not developing that fast as as other like control nests, let's say. And then when it's very end of the season, then this parental care is not that essential anymore. And then, yeah, the chick may fledge successfully. Then another aspect is like when something happened during the wintering period and they are coming to the colony and then cannot really find a partner, they are searching for another one. And then very much depends on the spot, on the situation. Some of them will be lucky enough and may find a partner on time, and then they may try to breed with the new partner. So these are newly formed pair, which we have the 6 points. I'm so proud of. And then the alternative is like they are hanging around in the colony and probably searching for the partner, but not really breeding in this year. And then only next year they would be more successful. So that's complicated process.
Okay, we have an online question, which is, I think you've answered it more or less the same, but anyway, I'll repeat it. There could be sex differences in the time spent caring for chicks and eggs. Are the sex differences apart from the coordination? Which I would add to the fact that some of the, if you do long trips, you care for yourself more than for your chicks. Could it be that those parents that do not coordinate are actually because one of the members of the pair is being selfish and is doing more long trips than short trips?
That's an interesting question. And the thing is, like, we know that for the incubation, they share the duties equally. For the chick rearing, they feed with the same frequency. Male and female, they provide the same amount of food. But as it comes to the duration of the foraging trip, when you compare the short duration, so these trips which are performed for the chick needs, they are of similar duration for males and females. But if you compare long trips, females, they stay longer on the sea than the males. I wouldn't say this is selfish, though, but it's pretty apparent, whatever season you look at, that females spend more time on the sea during their long trips. For now, the explanation for this behavior or like hypothesis is like they pay bigger costs of doing the same for the males, so they need more time to rest and restore the reserves. That is why the long duration trips are a little bit longer.
I just wanted to ask if, as this coordination is pretty important to the survival of the species, if before forming a pair, they test how good they would coordinate somehow, or if they just hope it works out the longer the pair stays together.
Yeah, that's a good question, but really, really hard to measure. I mean, during the mating period, they've got a lot of pair behaviors, like they stay together for a long time, so they can actually look at each other. Like the males, for example, they may see how faithful their females are. And then they also interact to each other, like making this kind of, I call it ducking. So you've got one bird in front of each other, and they are vocalizing a lot and shaking their heads. That probably has some meanings, but we haven't yet explored that. I mean, that's something which we really want to look at. And then they also frequently copulate within the pair, and then that could be also kind of a test, partners test, during this behavior on its own, partners, they can somehow evaluate, they mutually evaluate the quality. So, but it's really, really hard to tell right now. And but it seems like from this anecdotal observation we have that newly formed pairs are more like truly like looking at themselves and also trying alternatives. Like we've got only two such observations, or the observations of two pairs, but there were like new partners to each other, and for these pairs we could see a lot of successful extra pair copulations. For other pairs, they've been together for a long time. We didn't really see that. I mean, the males, they were trying to mate with extra partners, but the females, they were very much reluctant to these extra pair contacts. So this is probably like a long process of making a good partnership, but at the very beginning, the partners are like trying to secure the possible breeding attempt as much as possible. Yeah.
I wonder if have you checked how this coordination could change after a nest failure or an successful breeding event? Because I was thinking if you find if the chick dead, what happened the next breeding season? So maybe they decrease in their coordination to evaluate each other, or?
That's a very good question to look at. The problem is like they are pretty successful. Once the chick will hatch, they are pretty successful, like 80 to 90% of the nests, they are like, they fledge because they've got pretty high tolerance. They've got just one chick in the nest. So it takes really a lot of like failures on the way to make it really bad. But it's actually very inspirational question. We haven't looked at that. Maybe with some data collected over the years, we would have enough pairs that failed in one season and then we followed them in the next season. Yeah, for sure, I know that for pairs that failed during the incubation period, they stay together in the colony for a while, like really for a long time, which is kind of surprising because they are seabirds. They are like living on the sea mostly. The only reason they're coming back to the land is this egg. They cannot really incubate on the sea. So when they are done with this, they should they should depart the colony, but they don't really. They stay for a long time, and both male and female, they stay and they interact also. Yeah.
Okay, thank you very much again for a nice talk, and we'll hope to see you again soon and working with this thing.
Thank you very much. Thank you. Muchas gracias.